Welcome back to Future News. As always, an article linked to this quantum quandary can be found in the description below. Now, physics is full of surprises and it constantly challenges our intuition. The universe operates in ways we never expected. Just when we thought we had a grasp on the fundamentals, a new discovery forces us to reconsider everything we thought we knew, the latest iteration of this being the recent observation of what's called quantum rain. This phenomenon, observed for the first time in atomic gases, opens up a new realm of possibilities in our understanding of the quantum world. A team of physicists work tirelessly with unique mixtures of atoms, cooled to temperatures barely above absolute zero. Specifically potassium and rubidium atoms. They carefully manipulate these atoms using lasers and magnetic fields, creating a tiny, self-bound blob of atoms called a quantum droplet. This droplet is then placed within an optical waveguide, essentially a microscopic channel for light. So what happens next? The quantum droplet, confined within the waveguide, begins to elongate. It stretches out like a thin thread of honey. Then, something remarkable occurs. The elongated droplet breaks apart. It transforms into a series of smaller droplets. This process is reminiscent of a thin stream of water breaking into individual drops as it falls from a faucet. This breakup of the quantum droplet is not random. It is driven by a fundamental principle in physics known as capillary instability, also called the Plateau-Rayleigh instability. This phenomenon is responsible for the way a thin jet of water breaks up into droplets. It's also why beads of dew cling to a spiderweb. Capillary instability arises from the tendency of liquids to minimize their surface area. Surface tension, the force that makes water droplets form, plays a crucial role. In the case of the quantum droplet, the same principle applies. Even though the droplet is made up of atoms in a gaseous state, it behaves like a liquid due to the unique interactions between the atoms at such low temperatures. Quite fascinating objects, aren't they? We're talking about quantum behaviors that appears to mimic actions within the standard model of physics. These are gases, but they behave like liquids, which really blurs the lines between the traditional states of matter. It's like they can't quite decide what they want to be. The atoms within a quantum droplet are loosely bound together, almost like they're holding hands but not too tightly. They exhibit this incredible collective behavior, moving in sync, almost like a perfectly choreographed, synchronized swimming team. It's mesmerizing, really. And it's this collective behavior that gives the droplet its liquid-like properties, even though, deep down, it remains a gas at its core. Now, the observation of capillary instability in these quantum droplets is particularly significant. It provides solid evidence that these exotic systems can mimic the behavior of classical liquids. This, in itself, is a remarkable finding. But what's even more exciting is that this discovery opens up entirely new avenues for studying the fundamental nature of liquids and the transitions between different states of matter. The possibilities here are just endless. The discovery of what we're calling quantum rain is, well, not just some fascinating scientific curiosity. No, it's so much more than that. It holds potential implications for the development of future technologies. Imagine that. Researchers are already thinking about how arrays of quantum droplets, precisely controlled and manipulated, could serve as the building blocks for new quantum devices. And these devices could have applications in quantum computing, sensing, and even communication. It's like opening a door to an entirely new world of possibilities. The ability to create and control quantum rain gives us an extraordinary new tool to probe the mysteries of the quantum world. And as we venture further into this strange and wonderful realm, we can expect even more surprises. Who knows? There could be groundbreaking discoveries just around the corner, discoveries that might shape not only the future of technology, but also our very understanding of the universe. Isn't that simply thrilling? Now, don't forget to like, subscribe, and share this video with a friend. Thank you very much for watching. Stay tuned.